let's look at motion along a line, that is one dimensional motion. Okay, now whenever we talk of motion, we are interested in the displacement with respect to time, and we represent it as s of t, and usually this would be equal to some expression, okay, with t as a variable. Now, if using this, we have to figure out the velocity of the object with respect to time, then we would be differentiating s of t. And similarly, using v of t, if we differentiate it, we get acceleration with respect to time. Okay, so keeping this in mind, let's solve some problems. Let's say we are given as given s of t as minus t cube plus 26 t square minus 169 t. We have to figure out v of t and a of t, that is velocity and acceleration. To figure out v of t, we have to differentiate s of t with respect to dt. So let's do that. D by dt of minus t cube plus 26 t square minus 169 t, which gives us minus 3t square plus 52t minus 169. So that is the expression for velocity. Now for acceleration with respect to time, we would be differentiating with respect to time the velocity, that is d by dt of minus 3t square plus 52t minus 169, which gives us minus 60 plus 52. Right? Now, in the first problem, I have written it step by step. Depending on the context, you can directly start writing. So let's say s of t is given as t cube minus 14t square. V of t we have to figure out. So v of t is going to be 3t square minus 28t. So we are differentiating s of t. Now a of t is going to be 60 minus 28. So we have differentiated v of t to get the acceleration. Okay. Third one, s of t is given as minus t cube plus 8t square. So velocity would be minus 3t square plus 16g, and acceleration would be minus 60 plus 16. Fourth one, s of t is given as t cube minus 22t square plus 121t. So v of t would be equal to 3t square minus 44t plus 121. Acceleration would be 60 minus 44. Okay. Fifth one, s of t is given as t cube minus 23t square plus 120t. Velocity would be 3t square minus 46t plus 120, and acceleration would be given by differentiating v of t, that is 60 minus 46. Sixth one, s of t is given as t cube minus 12t square. So v of t would be 3t square minus 24t, and a of t is going to be 60 minus 24. So this is one series of questions. Pretty straightforward, just pure differentiation. Now let's see whether we can look at a slightly more complicated questions. Now let's say s of t is given as minus t square plus 18t minus 72. Okay. Now remember, t we are interested in is in the interval 4 to 14. Now what we have to figure out is the distance and the displacement in this interval. Okay, now remember, displacement, we are really interested in the direction, because if it is going towards the right, if the object is going towards the right, we take the velocity as positive, right? Whereas if it is going in the other direction, we take it as minus. Whereas the distance is always plus. Okay, so we need to know the actual direction in which it is moving in this interval. Okay, so to figure out, does it change direction in between, we have to know when exactly when the velocity is zero. So velocity would be what? Minus 2t plus 18. And we equate it to zero to figure out at what time this direction changes. So this would be minus 2t equal to minus 18, that is t equal to 9. So at 9, time is equal to 9, the object changes direction. That means our interval 4 to 14, actually we have to split it up into 4 to 9 and 9 to 14. And now we have to figure out in which direction this is going, or in which direction this is going, and figure out the displacement. So S of, so first what we'll do is we'll look S of 4 till 4, what is the displacement? That is 0 to 4. So that is going to be, if we substitute the value of 4 in this, we get minus 16. S of 9 is equal, so we are looking at displacement at end points of the intervals. This would be 9, and S of 14 is going to be minus 16 again. So now what we do is we figure out the displacement here, displacement here. So A is equal to, from S4 to S9, what is the displacement? That would be given by S of 9, displacement at t equal to 9 minus displacement at 4. Displacement at 9 is 9 minus displacement at 4 is minus 16, which gives us 9 plus 16, that is 25. Okay, now the second interval, the displacement is going to be S of 14 minus S of 9. This would give us S of 14 is minus 16 minus S of 9 is 9, which gives us minus 20. So here it is 25 and here it is minus 25. So therefore, displacement, remember here we are bothered about the signs, that is the directions. So we can't ignore the plus or minus. So the displacement in the interval of 4 to 14 is going to be what? A plus B, which gives us 25 plus minus 25, which is 0. That means the displacement of the object in that interval is 0. Okay. What about the distance? Here we are not bothered about the signs, the direction. So absolute value of A plus absolute value of B, which gives us 25 plus 25, which is 50 units. So this distance traveled is 50, but you are back to wherever uh, you started off with in that interval. Okay, so that was the 7th problem. Now let's look at the 8th problem. From now onwards, till I mentioned, we are given the displacement expression. So here it is minus t square plus 7t plus 78, and the interval that is we are interested in is 2 to 5. What we have to figure out is the distance and the displacement. Okay, so we need to know where exactly the direction changes, for which we require the velocity. Velocity is going to be minus 2t plus 7 equate it to 0 to figure out where exactly the velocity is 0. That gives us minus 2t equal to minus 7. That means t equal to 7 by 2. Don't convert it into decimals because it makes your calculations a little bit more tedious. So now our interval, which was 2 to 5, becomes 2 to 7 by 2, which is approximately 3.5, and 7 by 2 to 5. So again, look, take the endpoints and figure out the displacement. So S of 2 is equal to 88. S of 7 by 2 is equal to 361 by 4, and S of 5 is equal to 88. Displacement in the first interval is going to be S of 7 by 2 minus S of 2, which gives us 361 by 4 minus 88, which gives us 9 by 4. And B is equal to S of 5 minus S of 7 by 2. So which means 88 minus 361 by 4, which is going to be equal to minus 9 by 4. So therefore, displacement is going to be A plus B, which is 9 by 4 plus minus 9 by 4, which gives us 0. So again, the displacement is 0. Now, what about the distance? Absolute value of A plus absolute value of B, which gives us 9 by 4 plus absolute value of minus 9 by 4 is going to be 9 by 4, which gives us 18 by 4, which gives us 9 by 2 units, whatever it is. Okay, now let's look at the ninth one. S of t is given as t square minus 17t plus 60. Again, we have to figure out the displacement and the distance covered in the interval 2 to 11. Okay, so V of t is equal to 2t minus 17, equate it to 0 to figure out when exactly the direction changes. So 2t equal to 17, t is equal to 17 by, okay. Now, which means our interval 2 to 11 gets split into, because 17 by 2 is around 8.5, is 8.5. So this will be 8 to 17 by 2, and from 17 by 2 to 11. Again, take the endpoints and figure out the displacement. So S of 2 is going to be 30. S of 17 by 2 is going to be minus 49 by 4, and S of 11 is going to be minus 6. And the displacement in the first interval, that is 2 to 17 by 2, is going to be uh, S of 17 by 2 minus S of 2, which gives us minus 49 by 4 minus 30, which gives us minus 169 by 4. And B, that is the displacement in the second interval, is going to be S of 11 minus S of 17 by 2, which gives us minus 6 minus minus 49 by 4, which if we evaluate it, we get 25 by 4. So our displacement is equal to A plus B, that is minus 169 by 4 plus 25 by 4, which is equal to minus 144 by 4, which is equal to minus 36. And the distance traveled would be absolute value of A plus absolute value of B. which gives us 169 by 4 plus 25 by 4, which is equal to 194 by 4, which is 97 by 2 units. Let's look at the 10th one. S of t is equal to t square minus 4t minus 32. And the interval is 2 to 3. In this interval, what is the distance and the displacement? That is what we have to figure out. Okay, so to figure out where exactly the direction is changing, we differentiate s of t to get v of t. That would be 2t minus 4. We equate it to 0. So 2t equal to 4, t is equal to 2. That means at t equal to 2, the direction changes. But this 2 is on the boundary of our interval. So that means our interval doesn't get split. So we directly figure out the displacement at the endpoints. So S of 2 would be equal to, again we do the substitutions, we get minus 36, and S of 3 is equal to, again if we do the substitution, we get minus 35. Now here there is only one interval, so now since there is a single interval, we can directly do the figure out the displacement. So displacement is going to be S of 3 minus S of 2, which gives us minus 35 minus 35, which gives us minus 35 plus, no, one was supposed to be 36. So S of 2 is 36. So this is 36. So this will be 36, which means 1 units is the displacement. Okay. Now what about the distance? Now intuitively we know that the distance is also going to be 1. Why? Because there is no change in direction. So displacement and distance remain the same if there is no change in direction in a one dimension motion. But still, let's evaluate it. Distance is going to be magnitude of A minus magnitude of B would be equal to magnitude of A is 36 minus magnitude of B is 35, which is equal to 1. So that means whenever there is no change in direction, the displacement and the distance remains the same. Okay, 11th one. S of t is equal to t square minus 18t plus 77. The interval that we are interested in is 6 less than or equal to t, which is in turn less than or equal to 12. Okay. Again, we have to figure out where the direction changes. Does it change in this interval? So v of t is equal to 2t minus 18 equal to 0. So 2t equal to 18, that means t equal to 9. So at t equal to 9, that direction changes. So our interval actually gets split into 6 to 9 and 9 to 12. So this would be 6 to 12. And now we look at these two intervals one by one. So S of 6 is equal to 5. S of 9 is equal to minus 4. And S of 12 is equal to 5. Now we need to figure out this displacement and this displacement. So let's say A is equal to S of 9 minus S of 6. S of 9 minus S of 6 would give us minus 4 minus 5, that is minus 9. B would be equal to S of 12 minus S of 9, which gives us 5 minus minus 4, which is 9. So displacement is equal to A plus B. which gives us minus 9 plus 9, which is 0. And the distance covered is equal to magnitude of A plus magnitude of B, which is equal to 9 plus 9, which is 18 units. Next, 12th one. Now, S of t is equal to minus t square plus 8t plus 20. And the interval that we are interested in is 3 to 8. So again, first we have to figure out when does the object change direction. So v of t is equal to minus 2t plus 8 equal to 0, minus 2t equal to minus 8, so that is t equal to 4. So at t equal to 4, the direction changes, and this 4 is in this interval. So our interval 3 comma 8 gets split into 3 comma 4 and 4 comma 8. Okay, now let's look at the endpoints and see the displacements at those endpoints. So S of 3 is equal to 35. S of 4 is equal to 36. And S of 8 is equal to 20. Okay. Now, let's figure out the displacement here and here. So A is equal to S of 4 minus S of 3, which gives us 36 minus 35, which is 1. And B is equal to S of 8 minus S of 4, which gives us 20 minus 36, which is 16, minus 16. What would be the displacement? Displacement A plus B. So 1 minus 16, that is minus 15 units. And distance would be absolute value of A plus absolute value of B, which is 1 plus 16, which is equal to 70 units. Let's do a little bit more challenging ones. Okay, we are given S of t is equal to t cube minus 12t square, and t is always greater than or equal to 0. Okay, now what we have to figure out is when is the object changing direction, when is the object moving left or moving right, when is the object not accelerating, and when is the object slowing down or speeding up, right? Oh, so let's see. Uh, First of all, we will require velocity to know when the object is changing direction. So that would be 3t square minus 24t. Yes. And we will require a of t, which is 6t minus 24, to figure out the acceleration part of the problem. Okay. So v of t equal to 0. At this point, the object is changing direction. So that means 3t square minus 24t equal to 0. That means 3t times t minus h is equal to 0. That means t equal to 0 or 8. 0 is the boundary, so we don't have to bother about it. So we are interested in t equal to 8. Okay, so at t equal to 8, the direction is changing. So one is clear. Now, when is it not accelerating? When acceleration is equal to 0, right? So A of t equal to 0, which means 60 minus 24 equal to 0, which means 60 equal to 24, that means t equal to 4. So at this point, the acceleration is 0. That means it is not accelerating. Okay, so we have looked at this. Now we have certain intervals. What are they? T between 0 and 4. The other one is t between 4 and 8. Then we have t greater than 8. So we have 0 to 4, 4 to 8, 8 onwards. So these are the three intervals we have to look at. So let's see what is happening to velocity when the time is in between 0 and 4. So let's take it as v of 2. We could have taken v of 1 also, but let's say v of 2. That would give us 3 times 4, that is 12, minus 24 times 2, that is 24 times 2, that is 48, which gives us minus 36. Okay. Now what about acceleration at time 2? That would give us 6 to 12 minus 24, which is minus 12, right? So when both the velocity and the acceleration, they are both negative or they are both positive, then it means it is speeding up. And when the velocity is negative, it is moving to the left. Okay. Now let's look at this interval v of 5. V of 5 is going to be 3t square, that is 3 times 25 is 75, minus 24 times 5, that is 120, which gives us minus 45. Now a of 5 is going to be 60, 6 5 is 30 minus 24, which is 6. So which means when they are both velocity and acceleration are not of the same sign, one is negative, one is positive, so which means it is not speeding down, slowing down. And since again here it is negative velocity, it is moving to the left. What about t greater than 8? So let's take v of 10. V of 10 will be 3 times 10 square, that is 300, minus 24 times 10, that is 240, which gives us 60. And a of 10 is equal to 6 times t, that is 6 times 60 minus 24 equal to 36. Here again both are positive, so speeding up, and this is positive velocity, so moving to the right. So we have seen that the object is is not accelerating at t equal to 4. We have seen object slowing down and speeding up in what intervals. We have seen moving left, moving right in what intervals, and when is the object changing direction. Okay, now let's look at the 14th one. Same problem, the expressions are different. S of t is given as minus t cubed plus 18t squared minus 81t. Again, t is greater than or equal to 0, and we have to figure out all this. So again, we will require v of t, so minus 3t square plus 36t minus 81. And we will require a of t equal to minus 6t plus 36. So when is object changing direction? V of t equal to 0. That means minus 3t square plus 36t minus 81 equal to 0. 3 is common to all of them. So let's take minus 3 out. We get t square minus or 12t minus 27 plus 27 equal to 0. So this will disappear and we are left with this. So if we factorize this, we get t minus 9 3 is 27. So 3 and 9. That means t is equal to 3 or 9. Okay. So at these 2 points, the direction changes. Now, what about acceleration equal to 0? That would be minus 60 plus 36 equal to 0. That means minus 60 equal to minus 36, which means t equal to 6. So the intervals that we are interested in is going to be 0 less than or equal to t less than 3. So let's figure out this 0 to 3. Let me just mention it. 3 to 6, 6 to 9 and greater than 9. So here v of 1, let's take. V of 1 is going to be minus 3 plus 36. Minus 3 plus 36 minus 81, which gives us 33 minus 81, which is minus 48. Acceleration at 1 is going to be minus 60, that is minus 6 plus 36, which is equal to 30. Here, velocity and acceleration both are of opposite signs. So, which means it is slowing down. And since velocity is negative, it is moving left. Okay, now the second interval that we are interested in is 0 to 3 is over. So, now we have to look at 3 to 6. So, V of always choose a value which makes it easier for you to do calculations. So V of 5 is going to be minus 3 t square, that is minus 3 5 square, that is minus 75, plus 36 times 5, that is 180, minus 81, which gives us minus 75 plus 99, which gives us 24. Okay, that is velocity. So with this we know that it is moving right because it is positive. Now acceleration at 5 is equal to minus 6 times 5. So minus 30 plus 36, which gives us 6. Now here both are positive, velocity and acceleration. So that means it is speeding up. Okay, the third interval that we are interested in is from 6 to 9. So now here, whichever you feel comfortable with, let's take it as V of 7. V of 7 will be minus 3 times 49, that is minus 147, plus 36 times 7, that is 252, minus 81, which gives us minus 228 plus 252, which gives us plus 24. So again moving right because it is positive. Now acceleration at 7 is 6 times 7 minus 6 times 7. So 7 6 42 plus 36, which gives us minus 6. So again here if you notice, this is positive, this is negative. So that means it is slowing down. Okay. The next interval that we are interested in is t greater than 9. So let's take V of 10. So minus 3 times 10 square, that is minus 300, plus 36 times 10, that is 360, minus 81, which gives us 60 minus 81, which is 21. Okay. Now acceleration at 10 is equal to minus 6 times 10, that is minus 60, plus 36, which gives us minus 24. They both are negative. Velocity is negative. So which means it is moving left and it is speeding up. Okay, so that was the 14th one. 15th one. S of t is equal to minus t cube plus 12t square. T is greater than or equal to 0. That means we are not interested in negative times. We know we require, and what do we have to calculate? Let me just mention that. Okay, so we need V of t, so that is going to be minus 3t square plus 24t. A of t we require, that is going to be minus 60 plus 24. Changes direction when V of t equal to 0, that means minus 3t square plus 24t equal to 0. That means minus 3t times t minus 8 equal to 0. That means t equal to 0 or 8. And since it is on the boundary, we can ignore it. So it is changing direction at t equal to 8. Now, when is it not accelerating? When a of t equal to 0. That means 6 minus 60 plus 24 equal to 0. Minus 60 equal to minus 24. T equal to 4. At t equal to 4, it is not accelerating. Now we have to figure out the moving left or right and whether it is speeding up or slowing down. Now, based on this, we know the intervals that we are interested in. 0 to 4, 4 to 8 and greater than 8. So 0 to 4, 4 to 8 and greater than 8. Okay, so let's see. V of, let's say, 1 is equal to, what will this be? Minus 3 plus 24. Minus 3 plus 24, which is equal to 21. A of 1 is equal to minus 6 plus 24, which is 16. No, not 16. 18. Both are positive. Velocity is positive. So moving right and speeding up. Okay. Now V of, let's take 5. This would be minus 3t square plus 24t. So minus 3 times 5 square, that is minus 75 plus 24 times 5, that is 120, which is equal to, this is going to be 45. A of 5 is going to be minus 60 plus 24. So minus 30 plus 24, which is equal to minus 6. So again, here the velocity is positive, so moving right, and they are of different signs, so it is slowing down. Let's look at t greater than 8. So V of 10 is going to be minus 300 plus 240, which gives us minus 60. And A of 10 is equal to minus 6 times 10, that is minus 60 plus 24, which gives us minus 36. Both are negative, so speeding up, and velocity is negative, so moving to the left. There is no other direction, either left or right, because we are talking of one dimensional. Okay, 16th one. S of t is given as minus t cube plus 24t square minus 144t. T is again greater than or equal to 0. And what we are interested in figuring out is this. Okay. So now we know V of t equal to minus 3t square plus 48t minus 144. A of t is equal to minus 60 plus 48. Now, when is it changing direction? When v of t equal to 0, that means minus 3t square plus 48t minus 144 equal to 0. We can factor out minus 3. So that would be t square minus 3 ones 3 6 t minus 3 fours 12 2 24 3 eights 24 equal to 0. Minus 3 disappears. And now let's see whether we can factorize this. T minus minus. Why I write minus is it's easier to convert it into plus. Okay, so what do we get? 12 fours 48. 12 plus 4 is 16. So 12. Now the thing is, no, this is actually no, this should be plus because we have taken minus out. So when you multiply these two, minus 12 times minus 4 is plus 48, minus 12 minus 4 is minus 60. So that means t is equal to 4 comma 12. When is the acceleration 0? When minus 60 plus 48 equal to 0, that means minus 60 equal to minus 48. So t equal to 48 by 6, that is 6 8 48. So when t equal to 8, acceleration is 0. Now what are the intervals we are interested in? 0 to 4, 4 to 8, 8 to 12, greater than 12. So 0 to 4. So let's take v of 1. We have minus 3t square. So minus 3 plus 48t. So 48 minus 144, which gives us minus 99. A of 1 is equal to minus 6 plus 48, which gives us 42. Opposite signs, so slowing down, and velocity is negative, so moving left. Okay, 4 to 8, is that right? 4 to 8, yes, 4 to 8. So let's take v of 5. V of 5 would be minus 3t square, so minus 75 plus 48t, so 48 times 5 is going to be 240 minus 144, which gives us 21. A of 5 is equal to minus 60, so that means minus 30 plus 48, which gives us 18. Now here if you notice, both are positive, so it is speeding up. This is positive, so it is moving to the right. Okay, now 8 to 12. So 8 to 12. So let's take v of 10. This would give us minus 3 times 10 square, that is minus 300, plus 48 times 10, that is 480, minus 144. So this becomes 180, 300, 400, 480, minus 144, which gives us 36. Now let's look at acceleration at t equal to 10. This gives us minus 6 times 10, that is 60, plus 48. That would be minus 12. So here opposite signs, so slowing down. And because velocity is positive, it is moving to the right. Okay. Now, is there any other interval that we are interested in? Yes, greater than 12. Because remember, our time interval that is given to us is t greater than or equal to 0. So we have to look at t greater than 12 as well. Okay, so let's take v of 15. So this would be minus 3 times 15 square plus 48 times 15 minus 144, which gives us minus 3 times 225, that is minus 675, plus 48 times 15, that is 720 minus 144. This will come to minus 99. Now A of 15 is equal to minus 60. So minus 6 times 15 plus 48. 15 6 90. So minus 90 plus 48, which is equal to minus 42. Both are negative, so speeding up, and velocity is negative, so moving. Okay, so now let's look at the 17th problem. S of t is given as t cube minus 11t square. T is greater than or equal to 0, right? And again, we have to figure out the same old thing. Okay, we know we require v of t, so let's differentiate 3t square minus 22t. We know we require acceleration, so a of t is equal to 6t minus 22. We'll change direction when v of t equal to 0. That means 3t square minus 22, t equal to 0. We can take t common out. So t times 3t minus 22 equal to 0. That means t equal to 0, 22 by 3. And 0 is on the boundary, so we can ignore that. So at t equal to 22 by 3, the direction changes. Now what about a of t? When will acceleration be 0? So when a of t equal to minus 22 equal to 0, 60 equal to 22, t equal to 22 by 6, which is equal to 11 by. So at 11 by 3, acceleration is 0. So what are the intervals we are interested in? 0 to 11 by 3. 3, 3 is 9. So 3 point something. Here it is 3, 7 point something. Okay. So 0 to 11, then 11 by 3 to 22 by 3, and then greater than 22 by 3. So these are the intervals. It's better to write it down because sometimes what happens is the last one we will miss out. Okay. So let's pick a value in between these two. Simplest one is 1. So v of 1 is equal to 3t square minus 22t. So 3 minus 22, which is equal to minus 19. A of 1 is equal to 6 minus 22, which is minus 16. Velocity is negative, so moving left. Both are negative, so speeding up. Okay. Now, here in this case, let's take, this is 3.33, this is 7 point something. So let's take v of 5. So we have 3t square minus 22t. So 3 times 25 minus 22 times 5, which gives us 75 minus 110, which gives us minus 35. Now what about a of 5? That gives us 6 times 5, that is 30 minus 22, which is equal to 8. Opposite signs, so slowing down. Velocity is negative, so moving left. Okay. Now what about 22 by 3? Greater than 22 by 3. So let's take this as v of 10. V of 10 will be 3 times 10 square, that is 300, minus 22 times 10, that is 220, which gives us 80. A of 10 is equal to 60, that is 60 minus 22, which is equal to 38. Now here both are positive, so speeding up, and this is positive, so moving to the right. And finally 18th one, S of t is given as t cube minus 23t square plus 120t. T is greater than or equal to 0. And what we have to figure out is the same old thing. So we know we require V of t. So 3t square minus 46t plus 120. We require A of t, which is going to be 60 minus 46. It will change direction when V of t equal to 0. That means 3t square minus 46t plus 120 equal to 0. And here we can't really factorize this. Because 46 is not a multiple of 3. Okay, so which means we are going to use the quadratic equation, which gives us two values of t, that is 12, 12 6 is 72, and 10 by 3. Actually, I should have written 10 by 3 comma 12. Okay, anyhow. So at these 2 points, the velocity will be 0. That means it will change direction. Okay, so now when will the acceleration be 0? When A of t is equal to 0. So A of t is 60 minus 46 equal to 0. That means 60 equal to 46, t equal to 46 by 6, 2 2s, 2 3s, 2 3s. So 23 by 3. So whenever you have get fractions, no, never convert it into decimals, because then your calculations goes into decimals, which makes it complicated. Okay. So what are the intervals that we are interested in? Roughly speaking, this will come to 7 point something something, and this will come to 3 point something something. So the intervals that we are interested in is 0 to 10 by 3. Then we are interested in 10 by 3 to 23 by 3. Then we are interested in 23 by 3 to 12, and then greater than 12. So these are the 4 intervals that we have to consider. So let's take it one by one. In between 0 and 10 by 3. Okay, so let's take 0 to 10 by 3. Let's take V of 1. V of 1 will be 3t square, that is 3 minus 46t, that is minus 46, plus 120. This comes to minus 43 plus 120. You don't even actually have to do this calculation. You know it is going to be positive. We are only interested in the sign part. Acceleration of at 1 will be what? That is 60 minus 46. So 6 minus 46, which is minus 40. Opposite signs, so slowing down. And it is positive, velocity is positive, so going to the right. Okay, now next interval is 10 by 3 to 22 by 3. So this is going to be 3.33 to 7 point something. So let's take 5, because its calculations are simple. So V of 5 is equal to 3 times 5 square. That is 3 times 25, 75, minus 46 times 5. That is minus 230. Plus 120, which gives us 195 minus 230, which gives us a negative value. A of 5 is minus 60 minus 60 minus 46. So 6 fives, 30 minus 46, which is again a negative number. Yes. So since both are negative, speeding up. Since the velocity is negative, it is going to the left. Okay. Any other intervals? Now 23 by 3 to 12. So what shall we take? This is 7 point something to 12. So let's take V of 10. V of 10 is going to be, I'm just going to write the result, minus 40, and A of 10 is equal to a positive number. Again, opposite signs, so slowing down, and it is velocity is negative, so moving to the left. Now greater than 12. So let's take V of 15. which would give you a positive value. A of 15 will give you again a positive value. So this will give you that the object is speeding up and it is going to the right. So that was motion along a line, that is one dimension motion. That's it for now. Bye.